Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's Learn How to Sudoku, and I think it's episode 4, and it's with the very easy puzzle Nabnerix by Sudoku. And here are the rules. Just a note, these are all the The Learn How to Sudoku series is going to be essentially a series where basically I'm going to try to explain things slowly and more in depth. So as a heads up, that's what this Learn How to Sudoku series is going to be about. Anyways, on to today's puzzles and its rules. Nabnerix by Sudoku, and here are the rules. Normal Sudoku rules apply. That is, each row, column, we can get a column there, and 3 by 3 region has to contain the digits from 1 to 9 once each. Nabner lines. The golden lines are Nabner lines. That is, on such a line, there may not be consecutive or repeated digits. So, for example, if this had a 5, you could not have a 4 or a 6 along this lines, and you can't have a 5 also on the line because you can't have repeats and you can't have consecutive numbers on the same Nabner line. And Nabner is just Renban spelled backwards. So if you know what a Renban line is, Renban's digits on a Renban line must be consecutive. So Nabner is the opposite of that. Nabner lines, they cannot be consecutive on a Nabner line. So that's Nabner line rules. Xsums. Clues outside the grid indicate the sum of the first x digits in the respective row or column where x is the first digit seen from the clue. So, for example, this is all the digits outside of the grid, all the numbers outside the grid, basically are xsum clues. And the clues outside the grid indicate the sum of the first x digits in the respective row or column, where x is the first digit seen from the clue. So, for example, if this were a 3, that means the first 3 digits would have to add up to 12. If it were a 4, that would mean the first 4 digits would have to add up to 12. And that's how xsums works. And it's different for each one, right? For example, this could be 3, and then it'd be the first 3 digits must add up to 19. Or if it's 5, the first 5 digits must add up to 19, etc., etc. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, let's learn how to Sudoku. Okay, so first things first, what I like to do with xsums is usually figure out what numbers can be the x digit, right? And the x digit is always the digit that's next to the number, right, on that side. So this could be 5, because you could have 5, 6, 7, 8, 9 adding up to 35. You could have 6, 7, and 8 here, right? Because if it's 8, actually, you can't have 8. Oops. You cannot have 8 because if it's 8, that means you have one digit that adds up to 45 minus 35, which is 10. And no digit adds up to 10. No one digit can add up to 10. So this is 5, 6, 7. The 14 cannot be 2, could be 3, could be 4, but cannot be 5, because the smallest amount of xsum you can have with 5 is 1, 2, 3, 4, 5, which adds up to 15, which is already too large. 20 can be 3 because you have 3, 8, 9. It could be 4, it could be 5, but it cannot be 6 because the first 6 digits, the lowest 6 digits, add up to 21, and that's already too big. So it cannot be 3 because 3 with 8 and 9 only add up to 20. So this could be 4, 5. If you had 6, that doesn't work, right? So if you had 6, you could have 6 digits adding up to 21. But the problem, if you have 6 digits and you try to add up to 22, you would have to have the 6 going up to 1, going up 1 to 7. And therefore, there would never be a 6 itself in the first 6 digits, if that's the case. Therefore, this has to be 4 or 5. Now, this has to be 3, 4, 5. If it's 4, that means the 4 would be with a 5, because you'll have to be the 4 would eliminate the 4 in this cell, right? By normal Sudoku rules. So this can't be 4. If this is 5, this would have to be 4, and there would also be consecutive. And that's the whole point. Like that basically, if this is 4 or 5, it eliminates the possibility, the other 4 or 5 here. And therefore you would have a 4 and a 5 on the Nabner line. And those two are consecutive, and therefore that would break the Nabner line rule. So this can never be 4 or 5. Therefore, it has to be 3, which means the next two have to add up to 7. Next two digits have to next two cells, apologies, have to add up to 17, which would only be 8 and 9, adding up to that. Therefore, this is 3, 8, and 9. This can't be 4 because it's it's consecutive with 3, and on the Nabner line, you can't have consecutive numbers be on the same line. So this has to be 5. Now, this is 5 digits adding up to 22. We have at least 5 and 8. This can't be 1. This can't be 2 or 4. It can't be 3, 5, 8, or 9. It can't be 6 because it's consecutive with 5. Therefore, this is 1 or 7. Let's continue on with the x sums. The 19 could be 3. Could be 4. Technically, it could be 5, but it can't be because this 5 eliminates it. So this can't be 5 here specifically. It can't be 6 or above because 6, the first 6 digits, the low 6 digits add up to 21. So this is also 3, 4, or 5, right? The problem is that, yeah, it can't be 6. So this is 4 or 5, and it can't be 3 here, right? Therefore, this is 3. If it's 4, this would have to be 5, and on the Nabner line, it would have to, that would be consecutive digits, which is not allowed. So this has to be 3. Since this is 3, this can't be 4, because 3 and 4 cannot be on the same Nabner line, because they're consecutive, so this has to be a 5. Therefore, this has to be 3, 7, and 9. This can't be a 9 because of the 8, 9, 8, 9 pair in column 7. Therefore, this must be 7, and this must be 9. This, okay, so this could be 1, but not 2, because 2 is consecutive with 3. Cannot be 4, because 4 is consecutive with 3 and 5. Cannot be 6, because 6 is consecutive with 5. Cannot be 7, because of that 7. Could be 8, but cannot be 9, because the 9 is here. Same thing, this could be 1, but not 2 or 4, because those are 2, 4, or 6, because those are consecutive with 3 and 5. So this has to be 7, 8, or 9. We're not sure which. We have 5 digits, which cover 5 cells. So therefore, the rest of them cannot have those 5 digits. Therefore, it's 1, 2, 4, and 6 left. These are 1, 2, 4, and 6. 1, 2, 4, and 6. This can't be 3. And if it were 4, it would have to include a 3 with it, right? Because it would have to be 4 digits adding up to 10, which could only be 4, 3, 2, 1. But we already have a 3 in that row. Therefore, this can't be 4. Therefore, this must be 2, which makes this an 8. This is 12 digits, digits adding up to 12. It could be 3. It could be 3, 4, 5, or 3, 1, 7. It could be 4, actually. It could be 4. In fact, it actually has to be 4, because it cannot be 3, because the 2 is consecutive with 3. And it can't be 5, because it's too big. So this has to be 4, which means the rest of them have to add up to 8. And the only possibilities for 3 digits adding up to 8, 3 unique digits adding up to 8, is 1, 2, 5, and 1, 3, 4. But it can't be a 4 because we already have a 4. Therefore, this must be 1, 2, and 5. Well, 2 can't be in those two cells because of this digit, this 2 right here. So this can't be 2. Therefore, this must be 2 here. And this can no longer be 5 because of these 4 cells. So for this, we know these 3 digits add up to 10. And therefore, the rest of the digits add up to 35. Therefore, this must be a 6, because this counts the first 6 digits then. Therefore, this has to be 3, not 6, 3, 7, 8, and 9. Let's see. So the rest of this cell has to be 3, 6, 7, and 9. 3 can't be here because it can't be on the same Nabner line with 2 and 4. So this is 6, 7, 9. This cannot be 1, 3, or 5 because those are consecutive with 2 and 4. So it has to be 6, 7, 8, or 9 here. Okay, let's see. This is 5 digits adding up to 22. We know these 5 digits add up to 22. Therefore, these 4 must add up to 45 minus 22, which is 23. So this can never be 4 then, because if this was 4, this would have to add up to 23, but this adds up to 14, it says. Therefore, this is 3. We know 3 digits adding up to 14 and 5 digits adding up to 22. It must, those two sums must add up to 36. So therefore, this digit must be 45 minus 36. Therefore, it has to be 9. Which means this can't be 9, this is 8, this can't be 8, so this is 9. This can't be 3, 8, or 9, so this has to be 7. This can't be 3 or 7, this can't be 7. We know these 3 digits add up to 14, so therefore this has to be a 4. The rest of the digits are 1, 2, and 6. Okay. This digit cannot be 4 or 7. It cannot be 2, 5, because 2 is next to consecutive with 3, and 5 is consecutive with 6. So, and this can't be 9 anymore because of this 9. Therefore, this must be 8, which means these can't be 8. So it cannot be 3/4. The rest of these are 1, 2, 5, and 9, but 9 cannot be here. 2 and 5 can't be here because they're consecutive with 3 and 6 respectively. Therefore, this must be a 1. So these can't be 1. This can't be 1, 2, 3, 4, 5, 6, or 7. So this must be 8 or 9, but there's a 3-9 pair in box 4. So the rest of the box cannot contain a 3 or a 9. Therefore, this must be an 8. These can't be 3 anymore. Whereas a 3 in box 1, it can only be in one place, that is there. So this is 3. This can't be 2, so this must be 5. This can't be 2 or 5, so this must be 9. This can't be 5 or 9, so this must be 2. Okay. Let's see, what else are we looking for? What are these? This cannot contain 1, 2, 3, 4, or 8. So this is 5, 6, 7, or 9. But the 9 can't be here. Oh, this can't be, these two can't be 9. Whereas a 9 in box 1, it can only be here. So this can't be 9. This is 5, 6, or 7. This has to be 1 or 4 here. The rest of these 3 cells can be 1 or 5, or 4 or 6. But it cannot be 1, because if this were 1, then that would be consecutive with 2. And that's not possible in an Abner line. If this were 6, This could no longer be 6 because there's no repeats on Nabner lines. And then 5 or 7 would have to be there, but those are consecutive with 6, so therefore this can't be 6. So this is 4, 5. If this is 4, this can't be 5. If this is 5, this can't be 5. Because 4 would be consecutive with 5, and 5, there are no repeats allowed on a Nabner line. Therefore, this is 6 or 7. Okay, this can no longer be 9 or 8 because 9 is on the Nabner line, and you can't have repeats, and then you can't have consecutive numbers, so this can't be 8 and 9. This is 6 or 7. Okay, the first 5 digits add up to 19 here, which means in the first three digits here add up to 20. So therefore, these combined add up to 39. Therefore, this digit must be 45 minus 39, which must be 6. So this is 6. These can't be 6. This can't be 6. This can't be 6 anymore because you can't have repeats on the Nabner line. So this is 1 or 2. Let's see, what else do we have here? We have a 6, 7, 6, 7 pair in row 1. So the rest of the row cannot contain a 6 or a 7. Therefore, this is 1, 2, 8, or 9. And this is 1, 2, 8, or 9. But the 9 cannot be here because of this 9. So this must have a 9. In addition, we have a 1, 2, 8 triplet in box 3. That means the rest of the box cannot contain 1, 2, or 8. Therefore, this can't be 1 or 2. This must be 4, which means this can't be 4. This can't be 2 anymore. So this must be 1. This must be 2. This is 1 or 8. What's the last cell in box 3? It has to be 6. So this can't be 6 anymore. So therefore, this is 7. This can't be 7. So this is 6, which makes this 7. So the 9 has to be one of those two. If this was, well, we don't know. No, we don't know. Okay. So this cannot be 1, 2, or 3. It can't be 4 or 5, because if it's 4 or 5, the other 4 or 5 would have to be here, and those are consecutive, and that's not allowed. It can't be 6 or 7, because if that's 6 or 7, this would have to be the other 6 or 7, and those two would be consecutive, and that's not allowed on a Nabner line. It cannot be 9, and again, it can't be 1 or 3, because those are consecutive with 2. Therefore, this must be an 8. So this is 8, which forces this to be 1. This can no longer be 1 because of the Nabner line. These can't be 1, and these can't be 2 or 8. So this is a 1, 9, 1, 9 pair in box 2, which means the rest of the box cannot contain 1 or 9. So this can't be 1. We have a 4, 5, 6 triplet. Therefore, 4, 5, and 6 can't be in the rest of the box. So this must be 2 and 3 and 2 and 3. So this can't be 1 anymore. So this must be a 5. This has to be a 1 then because of that. This is 8, so this can never be 7 because you can't have consecutive digits on the same Nabner line. So this is 6. This can't be 5 then because you can't have 5 and 6 together on the same Nabner line because those are consecutive. So this has to be 4. This cannot be 4, so this is 5 or 6. This can't be 1 anymore, so this must be 4, which means this can't be 4. That's a 1. What can these be? This cannot be 1, 2, could be 3, can't be 4, could be 5, but can't be 6 or 7, and it could be 8. If this were 5, that would mean this would have to be a 6 on the Nabner line because you can't have repeats, but then those are consecutive, so therefore that wouldn't work for that Nabner line either, so this can't be 5. Let's see, what else do we have? For the same reason, this can't be 5 or 6 here either. So this can't be 1, can't be 2, can't be 4, can't be 5 or 6, but it could be 3, 7, 8, or 9, but no 8. So if this were 8, this could not be 7 or 9, and it would have to be a 3, because the 7 and 9 would be consecutive with 8. If this was 3, this would have to be 7 or 9. So either way, there's a 3 in one of these two cells. Okay. Let's see. What can this be? It cannot be 4, 5, 6, or 7 because those are consecutive or the same as this digit. It can't be 1 or 2 because of this 1 or 2. Cannot be 9 because of that 9. So no 1, 2. It could be 3, 4. It cannot be 5, 6, or 7, and or it could be 8. Okay. These cannot be 1, 5, 8, and 9. It cannot be 6 or 7 because of this 6 or 7. It can't be 1 or 2 because then the other 1 or 2 would have to be here, and that's not allowed. So no 1, 2. It could be 3. It could be 4. It cannot be 5, 6, 7 because of this 6. It cannot be 8 or 9 because of those 8 and 9. Therefore, this is 3 or 4. Therefore, if this were 3 or 4, the other one would have to be the other 3 or 4, and that's not allowed on the Nabner line because then those would be consecutive. Therefore, this must be 8, which forces this to be 3. This can't be 3 anymore, so that can't be 3. That can't be 3, therefore it's a 9. This is a 3. This can't be 6. This can't be 6. This can't be 8 anymore. Therefore, we have a 7, 9, 7, 9 pair in row 4. That eliminates 7 and 9 from the rest of the row. So this can't be 7 anymore, so this therefore it's a 5, which makes that a 7. This can't be 1 anymore, so this must be 7. This can't be 1, therefore this is 2 or 6. This can't be 1, and this can't be 1, and this can't be 1. Where's the 1 in box 9? It has to be here by Sudoku. This can't be 2 or 6, and those are the only two aside from 4, which could be here. So therefore, this must be 4. This must be 2 or 6. This can't be 6 because of this 6, so therefore this is 2, which makes this a 6, so therefore this can't be 6. Okay, this can no longer be 2, so this is 8. This is 8. What is going on here? This is 8, and that's 2. The 1... Okay, well, this can't be 3, so this is 2, which makes that a 3. Now, we have a 1 in columns 5 and 6 for row 7. We have a 1 in column 1 for row 1. Sorry, column 5 and 6 for row 1. So there's a 1 in column 5 and 6 in row 1, and there's a 1 in column 7 for row 7. Sorry, I don't think I said that right. Basically, there has to be a 1 in row 1 in specifically column 5 or column 6. In row 7, there's also a 1 in column 5 or column 6. So we know there's a 1 in column 5 or column 6 in row 1, and there's a 1 in columns 5 and 6 in row 7. Therefore, the rest of the columns in 5 and 6 cannot contain a 1. Therefore, 1 cannot be here because of that pair of 1s. 1 can't be here, 1 can't be here. So where is the 1 in box 5? It has to be here. So therefore, this is a 1. We have a 3, 4, 6 triplet in row 8. This can't be 3 or 4, so it must be 6. Therefore, this is 3 or 4. The rest of the box is 5, 7, and 8. This can't be 7, so this is 5 or 8. This is 5 or 8, but it can't be 5. Therefore, this must be 8. So therefore, that's 5. This can't be 8 anymore, so that must be 7. And therefore, this must be 8. This can't be 7. Therefore, this is 9, which forces that to be 7. That can't be 9 now, so this is 1, which makes that 9. This 1 eliminates that 1, which makes that 2, and that 1. This can't be 3 anymore, therefore this is 4. This can't be 4, so this is 3. Okay, what do we have left here? This is a 3, 6, 3, 6 pair. This can't be 3, therefore this must be 6, which forces this to be 3. 2 can't be here, 2 can't be here, 2 can't be here because of the 2's and surrounding boxes. Therefore, this must be a 2. I think we have all the 1s. We do have all the 1s. I think we now have all the 2's. We do have all the 2's. We have all the 3's. We do not have all the 4's. And those could be various things. This can't be 6 anymore, so it must be 5, which makes that a 6. 5 cannot be any of these two, so therefore it must be that one. This can't be 5, this can't be 5, therefore this must be 5. This is just normal Sudoku. 6's, we have all the 6's. 7's, we have... This has to be a 7. 8's, those are all done. This has to be 4. This is 9, and that's a 4. And that's how you solve Sudoku. Pretty straightforward. Yeah, I hope that introduced Nabner lines to you guys and X sums too, and I hope that made sense for you guys. And I'll see you next time on Learn How to Sudoku. Take care.